Today I'm going to show a demo of some new InterProcess communication capabilities in Pathwave Advanced Design System. InterProcess communication is a way of sharing data between applications. Typically, a software tool will facilitate interprocess communication by reading its inputs and writing its outputs to and from a standard location. Typically, these are called standard in and standard out. We've recently implemented a new set of process functions in ADS, which can be used to start and manage external processes, and then these functions will allow you to transfer data between ADS and any external program or application that supports interprocess communication. So let me show you how it works. For this demo, I'm going to be using Python, but keep in mind that these ADS commands are general. They'll work for any program that supports IPC. In Python, it's possible to read the standard input, which is really the command line, by using the input command. And it's also possible to write to the standard output. You can do that using the print command. So here's a simple script that will prompt for a standard input and echo that input in the standard output. Now let's run this from the command line. By the way, I've got Python installed on my machine, and I've configured the Windows path variable to point to this install. So now all I need to do is call the command Python and then type the name of the script, which is echo.py. And when I hit enter, now the script is waiting for me to put in the standard input. So I'll enter a number, let's say 20, and then the program just echoes that to the command prompt, which is the standard input. Okay, so now let me show you how to manage this Python program from ADS. To do that, I'll go to the ADS command line from the main window. This is just Tools command line. And then I'm going to execute actually a set of AEL commands here to show you how it works. First, I'm going to declare process equals process create object. That command is going to create a process object which I can reference for Python. Now I'm going to say process start, and I'll point back to that process object I just created. The second input for this function is going to be the path to the executable. In this case, this is the path to my Python install on my computer. And then the last input will be the argument, which for Python is going to be the name of the script to run, right? We said Python and then the script name. And this is in a list format. Now, once the process is started, it's possible to write data to the standard input. The command for that is process write data. So here I'll just enter a number and a return character. And then I need to wait until the process is ready to read a line before I can get data back. So I'll reference the process object in this command as well. And finally, I'll declare a return variable. Let's call it getBack in honor of the Beatles. And I'll assign it using process readLine. This will reference the process object to read the standard output. And finally, I'll display this output in a message box in ADS using the deinfo command. So now when I click apply to run this set of commands, you can see that the info window pops up with the standard output, which is really just an echo of what I put into it. Okay, now that the framework for this basic operation is out of the way, let's do something a little more interesting. Now, instead of doing this call and response one time in Python, let's put it in a loop. And I can do that by just adding a while true to the echo program that I had. And if I run this from the command line, it's just going to continually prompt for an input and then echo it back. And this will go on forever, or at least until I kill it using Control-C, so let me do that here. Okay, back to ADS. Let's set up that command set again on the echo loop program this time. Now, these are the same commands I just used in the last example, so the program runs as before and it echoes back the input, which is displayed in the info window. The difference this time is that I'm now able to go back and use ADS like normal, but this Python loop is still running in the background. And if I want to query it, I can do that anytime by using the command process write data. And I can wait for the return and read the output again with the process read line and display that new query back in ADS. So this is quite different than before. In prior versions of ADS, you could only communicate with the process that is run to completion. Now, in ADS 2023, you can communicate with a process while it's running. Now, since ADS has to manage the process, that's a requirement, by the way, you do have to kill a process that you've started when you don't need it anymore. And there's another command for this called process kill, and then, you just specify the process object again. Okay, let's expand this into one last example. Let's do something a little more interesting to bring all these concepts together. So here I'll set up a Python plotting routine. The script runs the same infinite loop as before, but this time we're going to pass in a list object with 2 variables. This will be an X and a Y. And we do that using square brackets at the standard input. And then let's invoke the Python command to evaluate this input. So that'll convert a string to a numeric list in Python. And once we have this numeric list, we can do a scatter plot of the 2 items in the list. And finally, the thing I realized was you need to add a pause command. This is a subtle detail to make the plot display properly when ADS happens to be controlling the script. So now I can go back to ADS and configure this process to run. It's the same command set as before, except this time I'm going to pass in a bracketed XY list rather than a number. And I'm also going to get rid of the read comments. We're not going to need those anymore. So now when I run this script, it will pop up a scatter plot of the 2 values I put in. So you can see the plot is popped up there. Now, the important thing to note is that while this plot is sitting there, I'm back in ADS and I can do other things like run a simulation. And later on, after the simulation completes and I look at data or do something, perhaps I want to add more data to this plot. Well, now I can go back to the command line, or this could just, this could be an AEL script. It doesn't have to be on the command line. And I can do a process write data. And what that's going to do is add another point to this existing plot. And the plot's going to update. So again, ADS isn't frozen here while this plot is up. The plot is continuing to remember the old data and it's adding in new data. And I can just keep adding points whenever I want. So in other words, we're interacting with a running Python session while it's in the middle of a loop. And this was never possible to do before these commands existed. Prior to this, it would be a one-time exchange. So I hope this illustrates the new capability clearly and concisely. To close, I want to point out that these commands are general. They work for any tool that supports inter-process communication. I use Python because that's my go-to scripting language, but you could use any tool for this. It could be another EDA tool or a scripting tool or anything, really. There's more information along with several examples in the ADS documentation. I encourage you to check it out. Thanks for watching. We'll see you next time.